Interactions Capstone Project by Emily and Adele. Essential question. How do Newton's laws describe the interactions between objects? Part 1. Forces, free body diagrams, and mass and weight.
Applied force is a hand pushing a brick to the right, moving in the direction of the polar push. Here's the brick, and here's the hand. The free body diagram for this would have balanced forces for Fn and Fg. It would also have applied force, Fa, moving to the right in the direction of the push. Normal force is the force perpendicular to the table that provides support for the apple. The free body diagram for this would look like this. It would have balanced forces for Fg and Fn. Fn is the normal force. The friction force is the force caused by contact with the table, slowing down the block opposite to the motion of the object. So here's the block and it's sliding along the table. Therefore, the free body diagram would have equal forces for Fg and Fn, otherwise known as balanced, and then a force going to the left opposite to the motion of the object, which would be Ff, the friction force. Tension force is the ornament hanging from a string, putting tension on the string in the direction of the pull. The free body diagram would have equal forces, the top force being Ft for F tension force. The bottom force would be Fg, force gravity. Air resistance or drag force is a frictional force that acts on the skydiver when traveling through the air opposite to the motion of the object. Free body diagram would look like this. Air resistance or drag force is a frictional force that acts on the skydiver when traveling through the air opposite to the motion of the object. The free body diagram would have balanced forces for F air resistance and force gravity.
The gravitational force is the force which Mars attracts the hat towards itself straight downwards. The free body diagram would only have one force. That force would be the force of gravity. The spring force is the force exerted by the spring that pulls and or pushes the keychain that is connected to it. Force spring and force gravity are what would be on the free body diagram. For mass and weight, we have a bear with a mass of 12 kilograms and a weight of 10 newtons. Weight is the amount or quantity of how heavy something is. It's the product of the object's mass. The mass is the quantity of matter in a body. It does not change. However, the weight does. For example, on the moon, where g equals 1.622 meters per second squared, the bear's mass is still 12 kilograms. However, on the moon, the bear's weight changes. The formula to find the weight is Fg equals mg. Substitute for m and g, and the weight of the bear on the moon is 19.464 newtons. We did it.
Part 2, net force.
Part 2 is the net force. Net force is the magnitude and direction, as well as the sum of all the forces acting on an object. In Newton's first law, the rule states that an object at rest tends to stay at rest and an object in motion tends to stay in motion with the same speed and in the same direction unless acted upon by an unbalanced force. In the first image, Sydney is standing at rest. Her free body diagram has a balanced force normal, and force gravity. The net force, in this case, would be 0. The block in the second image is a block sliding at a constant speed. The free body diagram has a balanced force normal, and force gravity on the y-axis. It also has a balanced air resistance force and a force friction and on the x-axis. Therefore, both net forces for each axis will equal 0. The girl falling in the third image has reached terminal velocity. She is no longer accelerating. The free body diagram includes force normal and force gravity. These two forces are balanced because she is not accelerating, therefore the net force is 0.
Newton's second law.
In Newton's second law, the net force is directly proportional to the magnitude of the net force and indirectly proportional to the mass of the object. In our example, the car is accelerating on a flat surface. The free body diagram includes force normal, force gravity, force acceleration, and force air resistance. The y-axis includes the first two forces and their balance. This means that the net force for the y-axis is 0. The x-axis includes the last two forces and they are unbalanced. Force acceleration is 50 and force air resistance is 30. This means that the net force for the x-axis is ma.
Part 3, Newton's third law.
Part 3 is Newton's third law. Newton's third law states that for every action there is an equal and opposite reaction. Action and reaction forces are never equal because they react to different objects. Our first example shows a baseball bat hitting a ball. The action is the bat pushing the ball, and the reaction is the ball pushing back on the bat. In our second example, we have a hockey stick hitting a puck. The action is the hockey stick pushing the puck, and the reaction is the puck pushing back on the hockey stick.